Welcome. This is the regression analysis course. My name is Nicoleta Surbat. I'm an associate professor in the Stewart School of Industrial and System Engineering. The lecture today is on multiple linear regression, and I will illustrate the estimation and prediction of regression line with a data example. Particularly, I will show you in this lesson how to do estimation and prediction of the regression line using the R statistical software. We'll return to the example. We're interested in the relationship between the advertising expenditure and sales in the presence of other variables that impact sales. The type of questions that we would like to address in this example are as follows. What are the average or mean estimated sales and the standard deviation for all offices with the same characteristics as those for the first office? What is a 95% confidence interval for this mean response? What sales would you predict for the first office if its larger competitor sales would increase at $303,000, assuming everything else fixed? What is the standard deviation of this prediction? What is the 95% prediction interval? In order to address the first set of questions, we'll need to first set up the data for the first office. So we extract the data for the first office, which is the first row in our data matrix, and we're interested in extracting the predicting variables 2 to 6. For estimating the standard deviation, I'll use the formula that I presented in the previous lesson. And for this formula, what we need is the estimated variance of the residuals, the sigma square hat, which we can extract it from the summary of the model. We also need the X star, which is the new data where the values of the characteristics of the predicting values for the first office. And also big X, which is a design matrix, consists of all values of the predicting variables for all offices. And then we put this together in a next row, and we based on the formula of the variance, and we get, in order to get the standard deviation, we take the square root of this value. In order to estimate the confidence intervals and also obtain the estimated mean response, we can use the predict R command. In this command, we need to input the information of the fitted model, which is model in this case, the vector of predicting variables, which is the new data for the first office, and we also need to specify what kind of interval we want. In this case, we want an estimation, we want a confidence interval. Going back to the questions, if we want the average estimated sales or the estimated mean response for sales, this will be the value 934. I'll remind you here that the units of the sales is in thousands, so we have to multiply this with 1,000. In order to get the estimated standard deviation, we can get this value from here. And in order to get the confidence intervals, we can get the lower and upper bound from the predict R command. How do we interpret this values? For other offices with the same characteristics as the first office, the average estimated sales will be in a range of 934,770, with a lower bound of the sales of 865,000 and an upper bound of 1,004,000. In order to address the second set of questions, we'll perform a similar exercise, except that we'll need to take into account that we have predictions. So now for the prediction, we need to change the competitor sales. So we'll change the value in the new data to 303 because the competitor sales increased to 303,000, and competitor sales are measured in thousands of dollars. In order to estimate the standard deviation, we use a very similar approach, except that now we have to take into account that for prediction, we need to add one sigma square hat, and but the rest is going to be the same. And for prediction, again, we're going to use the predict R command. We'll input in this command the model, the fitted model, the new data, where we change the comparator cells, and we also have to specify that we're interested in the prediction interval. So based on this output, the predicted sales of the first office, given a higher competitor sales, is now 911, is lower than the observed values. The estimated standard deviation is 62.62, and the confidence interval is between 775 to 1,046. Again, I'll remind you that sales are measured in $1,000. How to interpret these numbers? If the competitor's sales would increase at 303,000, the predicted sales will reduce with 23,719. And since this is prediction, the standard deviation will increase as well. To summarize, in this lesson, we learned how to implement estimation of prediction of the regression line along with derivation of the confidence intervals, and we learned how to do so with the R statistical software. Thank you.